File section 4, example 1. Two functions f and g are defined by f of x equals 2x plus 3 for f of x, and g of x is 2x minus 3. Find expressions for f of g of x. Well, f of g of x is f of, quick substitution, g of x is 2x minus 3, so that's f of 2x minus 3. Now my f function is whatever's in the bracket, double it and add on 3. So whatever's in the bracket, double it and add on 3. And I've just opened that up, so it's going to be 4x minus 6 plus 3, which is 4x minus 3. Part 2, find g of f of x. So g of f of x is going to be g of 2x plus 3. So if I go back to my g function, the g function is whatever's in the bracket, write it down, double it, and take away 3. So whatever's in the bracket, write it down, double it, and take away 3. So it's going to be 4x plus 6 minus 3, and that will be 4x plus 3. The question then says determine the least possible value of the product f of g of x times g of f of x. So I've got two results here for f of g of x and g of f of x, which was 4x plus 3 times 4x minus 3. I've opened that up, I've got 16x squared minus 9. Now the least possible value of that, so let's just have a wee think about it. Right, the least possible value of something squared is 0. If you times that by 16, it's still 0. If you then take away 9, it's 0 take away 9. The least possible value is definitely minus 9. Okay, section 4, example 2. Functions f, g and h are defined on suitable domains by f of x equals x squared minus 6 plus 10, g of x is 5 minus x, and h of x is log to the base 2x. Find expressions for h of f of x and h of g of x. So h of f of x, well f of x is x squared minus 10, minus x plus 10 rather. So h of f of x can be written as h of x squared minus x plus 10. Let's have a look at the h function. The h function is whatever's in the bracket, it's log to the base 2 of whatever is inside the bracket. So it's pretty straightforward. Log to the base 2 of x squared minus x plus 10. I'm now looking for h of g of x. So h of g of x is 5 minus x, so that's h of 5 minus x. Again, the h function is just whatever's in the bracket is log to the base 2 of whatever's inside the bracket. So the thing inside the bracket is 5 minus x, that's log to the base 2 of 5 minus x. Okay, so part B then says hence solve h of f of x minus h of g of x is equal to 3. So that's basically this bit, log to the base 2 of x squared minus x plus 10 minus log to the base 2 of 5 minus x is equal to 3. So this is now kind of morphing into a logarithmic equation. So let's have a go. So h of f of x log to the base 2 of x squared minus x plus 10 minus h of g of x log to the base 2 of 5 minus x is going to be equal to 3. Okay, so I'm going to use law 2 of logs. So that's log a minus log b is log a over log b. So it's going to be log to the base 2 of x squared minus x plus 10 all over 5 minus x is equal to 3. Now I'm then going to use my loop, which is that to the power that is equal to that. So 2 to the power 3 is equal to x squared minus x plus 10 over 5 minus x. 2 to the power 3 is 8. So that will give me x squared minus x plus 10 over 5 minus x is equal to 8. I'm then going to write 8 is 8 over 1 and cross multiply. Okay, so that will give me x squared minus x plus 10 times 1 will give me x squared minus x plus 10. And that's going to be equal to 8 bracket 5 minus x. I'm just going to expand things out now and bring everything across and make it equal to 0. So that's going to be x squared minus x plus 10 minus, well, 8 5s are 40, bring it across and it's minus 48 times minus x is minus 8x. Bring that across, make it plus 8x, and that's equal to 0. I'm going to collect together like terms, so x squared minus x plus 8x is plus 7x, and plus 10 take away 40 is minus 30, and that's equal to 0. So I'm now looking to factorise two numbers that multiply give minus 30, add together gives 7, so it's going to be x plus 10 bracket x minus 3 is equal to 0, which gives me x equals minus 10 and x equals 3. Okay, section 4, example 3. Functions f of x equals 1 over x minus 4 and g of x equals 2x plus 3 are defined on suitable domains. Part A, find an expression for h of x where h of x equals f of g of x. So f of g of x is 2x plus 3, so that's f of 2x plus 3. Now let's have a wee look at the f function. The f function is whatever's in the bracket is on the denominator, take away 4 with 1 up top. Alright, so whatever's in the bracket is on the denominator with a take away 4 and a 1 on top. So I can definitely simplify that. So 1 over 2x plus 3 minus 4, that will cancel down and just give me 1 over 2x minus 1. Part B, write down any restriction on the domain of h. Now, the domain is basically any numbers that get input into the function. So any x values. Now, what we're looking for here is to identify any numbers which we couldn't have go into the function, and that's a restriction on the domain. Now, generally speaking, with restrictions in the domain, there's two things to think about there. Two things in maths that you can't do is you can't divide by 0, and you can't take the square root of a negative number. So I can't identify anything here in this question to do with square roots, but in terms of not being able to divide by 0, I think I can get a bit of mileage with that one. So the thing on bottom here, the denominator, cannot be 0, and that's 2x minus 1. So what I would say with that one is the thing on bottom, the denominator, cannot be allowed to be 0. So 2x minus 1 can't be 0, 2x can't be 1, pretty simple, x cannot be 1/2, and that is the restriction on the domain.